All right. Hi, everyone. So my name is Michal Schwitz, and I'm product manager at SUSE, working on SUSE Enterprise Product Family. And with me, I have Flavio Castelli, distinguished engineer based in Italy, who is working on containers and related components. Today, we are going to focus on containers and the basics, pretty much how it all started, why does it matter, what are containers anyways, and then Flavio will show and talk about some of the details and technical tidbits. So let me start with how it all began. So there was this guy, his name is Malcolm McLean, in about, I guess, like 1950. He pretty much figured out the idea of containers. So before, the shipping of goods was just taking the loads in arbitrary boxes and shapes and forms. And he came up with the idea which lasts pretty much until today. So unified size, anything can fit on top of the other. You can stuff them onto ships, onto trucks, and it's very easy to use. So why does it matter in software business? Why does it matter in applications, development, services? Nowadays, pretty much any company does software development to an extent. So usually it's a collection of different components, boxes like this. So different functions, different programs, different sizes. So you see that the sizes don't match very easily, and it's kind of a mess to take care of them. So this picture looks much better. So you see it's easier. You can stack them on top of the other, one on top of the other, and mix and match and manage them way more easily than the mess you saw before. Again, how does it matter in software? So there is something called bimodal IT. So it's something like a Speedbang situation in a data center. So you have a data center with two parts. So on one side, you have mode 1, which is what we have been doing for years, like reliable stuff, waterfall-based, proper planning. It's like traditional projects and pretty long life cycles measured generally in months or even longer. That's on one side. On the other side, you have mode 2, which is over nowadays agile stuff, DevOps based. There is a lot of uncertainty. And the life cycles are pretty short. So they are measured not in months, but in weeks, days, and sometimes even hours. And you see like these two things do not match very well. So requirements on one side do not match what the other side can provide. And there is a lot of friction and disconnect between the two. So there is some kind of a bridge needed, meaning how to make these two guys talk to each other. So there was a research that said like 50% of organizations suffered from disconnect like that. Nowadays it's probably even more. So how to do this bridge? And containers actually come very handy. So imagine the situation where you have developers on one side and operations on the other side. And developers develop stuff on their notebooks or workstations or whatever they have, using the latest upstream, latest components. They get them from anywhere from their friends. And the stuff works in their environment, but when they take it over, throw it over the wall to the poor operations guys who need to manage that stuff. And they have a very different environment. So they have secure environment. They need to adhere to different measures, certified hardware, certified software, and very reliable environment in general. So they can't really afford turning the application down just for maintenance because the customers might get affected. So here the containers actually matter because the developers can package their stuff as a container and give it to the ops guys, which would just run it if done properly. And you kind of preserve the switch from different environment, and that's where containers come very handy. So what containers really mean, in fact. So everybody knows about containers nowadays. Everybody thinks they are great, but not everybody knows what that actually means underneath. So definition is It's operating system level or application virtualization. There are a couple of projects for that. It started with LXC, Linux containers, then Docker became popular, then nowadays it's Podman and Kubernetes and orchestration stuff and a lot of projects around it. So it spans many areas nowadays, so we are going to touch just some of them. And it spans many different data center types, on-premise, public cloud, private cloud, different architectures like Intel or ARM or others. So you can find nowadays containers pretty much everywhere. There are generally two views on containers. What operations understand is more technical and technology. So it's Linux operating system, components, it's kind of an image format, how the stuff is put together, the tools to manage, create and build containers, the isolation which is included in the kernel, and high density, so you can stuff many workloads on a single host. Obviously it's more lighter, faster when compared to traditional VMs and other orchestration management frameworks which are around and connected. The apps, the applications view is slightly different because it takes care about how the application is packaged so that we can take it and give it to somebody else. You can extend it so you can add the box here, box there. You can scale it up, scale it down depending on the demand. It's pretty self-contained, so you can easily manipulate it and share it further. There are two types of containers. System containers, not that used nowadays anymore, so it's full system in a container just without the kernel, and application containers. So it's like one process, one app just bound into a container. There is a container engine needed to run that application container. It's like Docker, Podman, or like, and that's where the most of the happening is going on nowadays. So that's where the ecosystem has exploded pretty much. Here is how it looks like underneath. So you can see the hardware, host operating system, and virtualization usually has a hypervisor layer and the individual VMs with kernel and guest OS and everything, binaries, libraries, applications, everything included. And system containers eliminate that intermediate hypervisor layer along with the kernel, and application containers go even further. So it's pretty much just the application which is confined and wrapped in a package with its dependencies, and that's it. Like really, that's about it. So it's you can see when you compare to the traditional VMs, is very small and very like confined. The advantages are somewhat obvious. So like it's very lightweight. There is a very little overhead when it comes to I/O or memory or stuff like that, because you eliminated the hypervisor layer in between, and the operating system as well. The isolation is still in place. The kernel does that, and you can do a lot of changes at runtime, like just tweaking the C groups and stuff like that. You can nest stuff, meaning you can run VMs and containers combined, and there is like no boot time at all because there's nothing to boot. I mean, you just start the process and there you go. Nowadays, there is much more than these kind of technology-focused advantages. It's about density, so you can stuff very many workloads on a single host as compared to virtualization. It's faster when it comes to spin up or changes, very little overhead, and it's also portable, meaning you can just take these packaged containers and give them to somebody else pretty easily. Limitations are coming from how containers are designed, so you can hardly run different OS and architecture because you are using a shared kernel. Like there are some options there, but it's not easily possible. And security is a bit of a concern because it's kind of shared kernel layer, and all the containers are using that shared kernel layer. And there are some measures what you can use, like namespaces or system call limits. You can use confinement. Obviously, if you are concerned, you can use virtual machines, and a lot of guys actually do it. So you can run VMs and the set of containers inside VMs if you are really concerned. So one has to be aware of these limits when combining containers or different containers into same environment or running them on a same host. Orchestration is a good topic because so far we've been talking, or I've been talking about containers, like pretty much on a single host or in general, but they are of only limited use, meaning you can run one or two or a couple. But the real advantage is when you are running multiple of them. So for that, you need the orchestration engine. Nowadays, it's pretty much Kubernetes all over the place. This engine takes care that you have multiple hosts running multiple containers, and this is all managed from like single place. The containers are spin up or killed when needed. It's possible to scale them down, scale it up. And the orchestration engine does all that, and it's really where the flexibility and power of containers is coming at. And with that, I'm getting back to the bimodal model I mentioned in the beginning, because with containers, you can actually create an environment which serves both the traditional guys with mode 1 operation and the mode 2 the agile DevOps, and have them collaborate together in a kind of a peaceful manner. So that's why it makes sense to have a look at containers, how to use them in a data center and how to leverage them, even if some of the apps might not be ready for that yet. This is a good illustration of what's going on around containers. So this is called CNCF Cloud Native Landscape. So I'm not going to describe all the boxes in there, but it's a good illustration about different pieces of the ecosystem, what's going on. And I mean, you can find the container runtime, container engines, the platforms, architectures, but also all the other stuff, which is like security compliance and key management and log management. All this is building on top of a basic container idea, container layer. And if you know, there is a clickable version of that on the CNCF web page. But really, there is a lot going on, and not everybody needs all of that. So I care that you pick and choose the right components. However, be aware of these immense options and pick the right ones which fit your use case. Right, and I guess with that, I'm going to head over to Flavio to dive deeper into the technical details.
Thanks, Michal. Thanks a lot. So now I will start by looking closer at some of the changes that we introduced inside of the containers module, which is part of SUSE Linux Enterprise Server. So before looking into what we added, I want to do a small recap about container standards. So as you have seen before, as Michal said, there are different ways to run containers, different ways also to build them. There is, all of that is important and is possible just because the Open Container Initiative, which is a foundation part of the Linux Foundation, has created two specifications. One is covering the runtime, so how to run containers, and the other one is covering the format of containers, so how containers are structured. And thanks to these two specifications, it's possible to have different ways to create, manage containers, and this makes possible to have innovation. This makes possible to avoid vendor lock-in, and this makes possible to avoid fragmentation of the whole ecosystem. This is what keeps everything tied together, but at the same time allows new projects to come up and take different approaches to solve certain problems. So I will focus in the beginning on how to run containers. And as Michal said, if you want to run containers across a fleet of machines, then Kubernetes has become the de facto way to do that. If you instead want to run containers on a standalone node, like your laptop, a single workstation, then there is the Docker open source container engine, which is fully supported by SUSE. But there is also another way to do that, which is by using a project called Podman. And the big news is that Podman is now fully supported by SUSE. So I will dig deeper into Podman in a slide. Before doing that, there was also a big change when it comes to container orchestration. So Kubernetes, as you all know, is the choice also of SUSE when it comes to manage a fleet of containers across different hosts. There are, however, different ways for Kubernetes to run these containers. And starting from the latest release of SUSE CaaS platform, our supported engine is now CRYO, which is a container engine optimized for the Kubernetes use case, which leverages runC, which is the same container engine used by Docker, the same container engine used by Podman, which also happens to be the the upstream implementation of the OCI runtime specification. So again, really important. As the first point on this slide, Podman is as a drop-in replacement of Docker. It really is relying on runC, which means that the behavior of your container is going to be the same. There is no surprise coming up for you. And given it's a drop-in replacement, you can also, do an alias of Docker to Podman, and all your scripts, all your already pre-existing knowledge about how to operate containers using Docker will still work just fine. The focus of Podman is on single node operation, as I was saying before. If you are familiar with the history of Docker, you will know that after the 1.13 release, Docker started also to focus a bit on multi-cluster operation with Docker Swarm. Podman doesn't have these features because Podman, again, focuses on single node operations. It has some big changes compared to Docker, but these changes are, let's say, hidden. They are inside of the architecture. So the first change, the biggest one is that it's daemonless. So there is no Podman daemon running on your system. There is no need to have a set of trusted users who are entitled access to the Docker daemon. So with Podman, everything is more slim, it's more secure in terms of the architecture, in terms of the management. So this is a big change compared to the Docker open source engine. Another change comes in the network side of things. So Podman is using the CNI network specification, which is a well-known and broadly used network specification. It's the very same one used by Kubernetes, used by Mesos and other projects. So again, it allows you to reuse some existing knowledge and standard. Podman also brings in some extra features. So the first one is the concept of pods, which is like the pods of Kubernetes. What does it mean for ones who are not familiar with it? Within a pod, you can put different containers, and by doing that, all these containers will be less isolated from each other as they would be usually. And these are some nice advantages that we will see pretty soon. There is also another interesting feature provided by Podman, which is the ability to run containers in rootless mode. So as I said before, there is no daemon running. There is no need to add users to a certain user group. With Podman, you can also start containers and operate containers as non-privileged user. There are some limitations, some caveats compared to running containers in a root with root privileges on the host, but this makes everything more secure compared even to the scenario where you would be running containers as root but using user namespaces. So this is really nice addition that is part of Podman since quite some time. It's also coming to Docker, to be fair, but Podman has that in the works since longer time. Now, I will dig into one nice feature of Podman that solves a pretty common problem for many users. So you want to run, many users want to run a containerized service and want, however, this service to be nicely integrated with the other services, traditional services, uncontainerized services that are running on a host. So basically what many users want to do is to have containers managed by the systemd process that is running on every Linux machine. So you could do that with Docker. However, due to Docker's architecture, where you have this daemon that is basically sitting between you and the end container, you would end up having quite some quirks and some corner cases. All of that is gone thanks to Podman architecture, which doesn't have this daemon. So with Podman, systemd can easily manage containerized workloads. So how to do that? Well, first of all, we will create a container. In this case, we are going to create a MariaDB container. As you can see, the syntax is like the one of Docker run. So we are starting a MariaDB container. We are putting that listening on localhost on this. Well, we are opening a port, not on localhost. We're opening a port on the machine running Podman. And then we can connect to this containerized instance of MariaDB by using the MySQL command. So this is pretty standard. What comes next, the last point of the slide, is how to create a systemd unit file. Podman has a nice feature which allows you to quickly generate a systemd unit file for any kind of container that is running on your system. So once you have started this container workload, you just have to do Podman generate systemd with the name of a container, and this is going to print to the standard output a systemd manifest for it. So to have it done in a more permanent way, what you have to do is just redirect the output of a generate systemd into a text file under etc systemd system. Then you just have to reload all the service definition, and then you just enable now, which means that it will start the service. You enable the MariaDB service, which in fact will just reach out to Podman and create a container for MariaDB. As you can see, this is really easy. From now on, you can just use journald to get the logs from your container. You can use systemctl, start, stop, whatever, to manage the container. All of that seamlessly without having to resort to Podman, and with systemd having full control over the container without any intermediate, like it would happen with Docker open source engine. The next thing I want to talk about is how to leverage pods, this concept of pods that is a nice addition to Podman. So the goal here is we are going to deploy a web application that is using a database. In this case, instead of using the usual WordPress example, we will instead deploy Nextcloud, and we will leverage MariaDB as a database for Nextcloud. So what are we going to do here is we are going to create a pod, and inside of this pod we will place two distinct containers. One is going to be Nextcloud, and this one is going to expose the web interface of Nextcloud to the world. The other one is going to be MariaDB, which is not going to expose MariaDB to the wall world. Instead, is going to expose MariaDB only to the Nextcloud container. And this is doable thanks to how pods are created and how network namespaces are handled by pods. So let's start, first of all, by creating a pod. So to do that, we just use the Podman pod create command, and we have to, at creation time of a pod, we have to also specify which ports have to be exposed to the wall world. In this case, we're going to map port 80 of a pod on port 80 on the host. This is the port used by Nextcloud, of course. As you can see, we're not exposing MariaDB, so MariaDB will stay secure. Next step, we are going to start MariaDB, and this is the same command that we have used before, a couple of slides ahead, with a single exception of the --pod flag. So this tells Podman to create this container inside of a pod that we previously generated. Finally, we create Nextcloud, and we connect that to MariaDB. So the creation of Nextcloud happens inside of the very same pod that MariaDB is using, as you can see from the --pod. And then we provide a series of environment variables that are specific to the Nextcloud container image. And these environment variables, some of them are related with where the database required by Nextcloud can be found. The important piece here, as you can see, the MySQL host is localhost. That's because the two containers are running inside of the very same pod. And by doing that, they are sharing the same network namespace, which means that the network stack of the two containers is the very same one, which means that localhost is the same on the two different containers. And then, hereby, localhost for Nextcloud is the same of MariaDB, and so MariaDB is reachable by Nextcloud in an easy way. Once this is done, we just have to wait a while for the containers to be pooled, for the database initialization to be done by Nextcloud. And once everything is done, we can just open Nextcloud web interface by visiting this port, the port 80, on the host where Podman is running. So as you can see, really easy. What we can do afterward is we can generate a systemd unit file for the whole pod. So as we have done before, we can generate a systemd unit manifest that can be leveraged to have systemd start all the container workloads at boot time. Here we do not have to create a manifest for MariaDB, another one for Nextcloud. We have to generate a manifest for the pod, and then Podman will just make sure that all the containers that are expected inside of the pod are up and running, and everything will still be managed by systemd as it was before. Another nice feature that Podman has is the ability to generate Kubernetes deployment files. So in this case, as you can see, we can do a Podman generate with a target cube, and this is going to create a YAML file which has Kubernetes objects defining all the different containers that are inside of the pod. So why is it nice? Well, a lot of users are new to Kubernetes because they usually start with managing containers on a single host, and when they have to do the transition towards Kubernetes, they feel lost because they have to learn a lot of things. So this provides a nice transitioning path for users that are beginning their journey into Kubernetes. But however, big fat disclaimer, the files that are generated by Podman are not really, fancy or good. They just get the job done, but they are definitely not something that an experienced Kubernetes user would write or use. It's a good starting point for you, so it's worth to be mentioned. So that's all for Podman for today. The next slide, I will focus on another tool, different tool that is now delivered to you inside of the containers module of SLAS. This tool is called ContainerDiv, and the purpose of the tool is to compare containers. However, this is not just, comparing containers from a file system perspective. It's not going just to tell you this file was created, this directory was dropped, this file was modified. It can do that, but the real value comes from the different kind of inspectors that ContainerDiv makes available to you. So there are inspectors for packages provided by apt-get or by RPM, but most interesting, there is the ability to look at files, packages that are delivered by, let's call them language-related package managers. So, for example, Ruby gems, Python modules installed through pip, Node packages installed through npm and such. So let's see some examples to show you what kind of value you can get from this tool. So first of all, before we start to inspect images, we have to get images. The nice thing about ContainerDiv is that it doesn't require you to have Docker or Podman, anything like that running. It does a static analysis of the containers, which means that it doesn't run them. It compares container images without executing them, which from a security perspective is also pretty nice. What you have to do is to have a tarball with the contents and the metadata of a container image that you want to expect. There are several ways to obtain such a tarball. You can use the Docker save or the Podman save command, or as I'm showing here in this slide, you can use another tool which is part of the containers module of SLES, which is called Scopio, which is a CLI tool that is focused on getting or managing container images and interacting with container registries. So here I'm downloading from the Docker Hub a container image called Mongo Express, which is a Node.js application. And on this slide, I'm showing you how to analyze two different versions of a very same image. So here we are using ContainerDiv, using the node inspector, and we are running a diff against the two versions of Mongo Express, 0.49 and 0.44. So here you can see a snippet from the output that ContainerDiv generates. Can show you that, for example, some packages have been updated. It's interesting, for example, to see that async package got a major update, a really big one. It went from 0.2.10 to 3.2.0. So there was quite some changes introduced from this point of view, despite the version of the image still be relatively close from each other. And it's also interesting to see, for example, which node packages are available only inside of one image, like inside of 0.54, we have a JSON stream, which wasn't used before. So this is pretty valuable information for someone who wants to debug a container, wants to do some supportability statement and such. It's also interesting to, for example, compare a container image against the base image from which it was created. In this case, the Mongo Express container image was created starting from the node Slim base image. So if we do another diff using the node inspector of the two images, we can see, for example, that we have a clear list of what are the requirements, the dependencies of Mongo Express. And we can also see some interesting facts. For example, the NPM package got somehow upgraded inside of the Mongo Express image. It went from 6.13 to 6.14. So an interesting change. Finally, there is also quite some value that can be obtained by looking at the packages done at the system level, so RPM packages or deb packages. In this example, I'm looking at the Nginx ingress controller, which is an image that is derived from the SLES12 SP3 base image. And by comparing this derived image with its base image, we can see all the packages that have been added by the Nginx controller, like offbind, bzip2, and such. But really interesting, we can see here version differences between the two images. And it's interesting to see how the base image, in this case, has a more recent bash version compared to the derived image. So why is that happening? Well, probably the Nginx ingress controller image that we're using has been built against an older version of this SLES12 SP3 image. And so some fixes, for example, are not available inside of this image. This is probably a stale image I add around, or if this is an image that you deployed in production that provides you some really nice and important information about the workloads that you are running. So ContainerDiv, again, really nice tool. Take a look into that. It really provides some valuable output. Now I'm showing you output provided in this format. It can also provide output in JSON format, which is nice if you want to script it and integrate that into any kind of workflow that you have in place. Having said that, that's all for today. Thanks a lot for having attended our talk. We hope you enjoyed it. And thanks again.
Thank you, guys. Bye-bye.